Welcome to Mountain Bike Physics, cornering on a flat surface. I'm going to start with the free body diagram. We're just using friction to hold us on the single track. What causes the bike to go around the turn is centripetal force, and that centripetal force is caused only by the force of friction. If you notice, our force normal and our force due to gravity are equal but opposites. They cancel each other out. The only thing that's holding our bike on the trail then is our centripetal force, which is created by a force of friction. We're going to use our coefficient of friction equation, which says mu equals force of friction divided by normal force. Rearrange it. We know that the force due to gravity is the same as the normal force. Force then of friction is equal to mu times force of gravity. Here's the solution to our first part of the problem. Force of friction is equal to mu times force of gravity. Force of gravity is equal to mass times acceleration due to gravity. We know that centripetal force is equal to mass times velocity squared over radius, which is the same as our force of friction. It's given a story problem, 100 kilogram mass, bike and rider, radius 50 meters. Velocity, trail was designed to max out at 25 miles an hour. Acceleration due to gravity, 9.81 meters per second squared. Remember again, this is a flat surface, no berm. First thing you want to do is convert your miles per hour to meters per second. And when you take the time to do that work, it's 11.4 meters per second. All right, so let's calculate force due to gravity. 100 kilograms times 9.81 meters per second is going to give us 981 newtons, force due to gravity. Our centripetal force, 100 kilograms, times 11.4 meters per second squared, divided by 50 meters. That will equal 260 newtons, which is also our force of friction. Coefficient of friction then is force of friction divided by normal force, 260 newtons divided by 981 newtons. Our answer, 0.265. A good coefficient of friction for this trail is 0.4. So we have plenty of chance to get around that turn without failure. Now, how fast could we go? Well, good ground, good tires, good skill. Let's calculate for our maximum velocity. Do that by using our force of friction equation. It's coefficient of friction times 981 newtons, which gives us roughly 392 newtons. Centripetal force, mass, velocity squared divided by r. Rearrange it to find the velocity. That'll be the square root of r times centripetal force divided by the mass of the bike plus rider. 50 meters times 392 newtons divided by 100 kilograms. Our velocity comes out to roughly 14 meters per second. When converted to miles per hour, is approximately 31 miles per hour. So we could have tackled this turn and stayed on course, stayed on our single track at speeds that would max out around 31 miles per hour.